Yeah, resolution of a velocity. The parallelogram law can be used to resolve a given velocity into two components. So there are infinite number of ways this can be done. So since we can describe any number of parallelograms on a given straight line as diagonal. In practice, the direction of the components are given, and the directions are usually in the right angle. So this is what we are talking about. So assuming that we have this diagram like this, now let's OP represent the given velocity as indicated here. Now, as suppose we wish to resolve into two components along OX and along OY. Is that okay? Then the OM and ON will represent the components of phi, a component of this velocity along this OS and then along OY respectively. Now, so to do this, we need to draw PM. Is that okay? This PM, we need to join this point to this point. Is that okay? To OS, and then we need to draw PN perpendicular to OY. So this is PN and this OY. So when PN is perpendicular to OY, that means we need to have right angle triangle here. So here we need to have a right angle triangle here also. Is that okay? So the OM and ON will represent the component of it along OX and then OY respectively. Now, if this angle, if angle XOP represented by theta here, yes, if SOP is equal to theta, then so to find this angle, so we can use cos. Since we know the component we are looking for is OM, and we have this line as velocity. Is that okay? So we can use the knowledge of a right angle triangle to find this angle. So if we use cos theta here, cos is what? Adjacent over hypotenuse. So the opposite side to this angle is line PM, right? Now this angle now, so here OM is the adjacent and then OP is the hypotenuse. So that is the reason why we are having cos theta is equal to OM over phi. That is, this line is the adjacent over what? Over phi. Now this component we are looking for, which is OM. So if you cross multiply here, you make OM the subject of formula. So OM will be equal to, you need to multiply this phi multiply cos theta, and that is the reason why we are having OM is equal to phi cos theta. Is that okay? Now to find this ON also, you know, this ON and then this PM, they are the same. Exactly, they have the same length. They have what? The same length. So what we are saying in essence is that instead of writing PM, you can replace PM with ON. Is that okay? Because they have the same length. Now this time around we have opposite and then hypotenuse, because this is ON we are looking for. Now, so we now have sine theta. Sine theta will be opposite over what? Hypotenuse. So the opposite is PM, and PM is the same thing as ON. So sine theta, that's why sine theta is equal to ON over phi. So to make ON the subject of formula, so you need to cross multiply. If you cross multiply, so ON will be equal to phi sine theta. Another way of doing this one is, since this one is parallel to this one, so if this angle is theta, this angle is also theta. this angle P here is also what? Theta. So if you are looking for ON here, so the side opposite to this angle that I'm pointing at here is angle ON here, and we have this longest side to be hypotenuse. Is that okay? So now I have sine theta here is equal to opposite over hypotenuse. Still the same thing. Is that clear? Still what? The same thing. So that is why we're having sine theta is equal to ON over phi. So which is velocity. So to make ON the subject of formula, so we now have phi ON is equal to phi sine theta. Now, hence, what we are saying in essence is that so velocity phi is equivalent to phi cos theta along line, making an angle theta with its own direction. Then together with the velocity phi sine theta, perpendicular to the what? Direction of phi cos theta. This is the direction of phi cos theta. This is the direction of phi sine theta. Is that okay? So that's exactly what we are saying here. That is, the velocity phi is equivalent to phi cos theta along a line, making an angle theta with its own direction, together with the velocity theta perpendicular to the direction of the what? Phi sine phi cos theta. Now, having get the concept now, let's now look at example 1. So find the resultant of velocity of 15 meters per second square and 20 meters per second at right angle to each other. At what? Right angle to each other. So now this question now. So let phi be the magnitude of the resultant velocity. Then let alpha be the what? Let alpha be the inclination of the resultant with 20 meters per second velocity. Is that okay? Now, so the first thing for us to do is to draw the diagram. Is that okay? I will have a right angle triangle. We need to draw the 15 meters per second along y-axis, then 20 meters per second along the what? X-axis. So let's have this is the diagram that I have here. So this is the first one. That's the first component, which is 15 meters per second. Then this is the second one, 20 meters per second. So then we need to find the angle of inclination here. Now, so to find phi now, to find this velocity here now, so using Pythagoras theorem, because this one is right angle triangle already. Is that okay? So if this one is right angle, well, this one is also right angle, this one is also right angle. Is that clear? Now, so if this side is 20 meters per second, so this line, that is the opposite line here, also will be opposite side will be also 20 meters per second. Is that okay? Now to now find v here now, using Pythagoras theorem, so phi square is equal to 15 square then plus 20 square, because if here is 20, here also will be 20. So that's why we are having v square is equal to 15 square plus 20 square. And 15 square is 225, then plus 20 square, which is 400. So if you add 225 plus 400, then you have 652. Now we are looking phi, so we need to find the square root of both sides. So square root of phi will give you phi, which is velocity, and square root of 625 will give you 25 meters per second. Is that okay? So this one is supposed to be 1 per second. Then to find this angle now, so we know to find the tangent of this angle now. Tangent is what? Opposite over adjacent. Opposite over what? Adjacent, because these are the two things we have now. We have this opposite to be 15, and we have adjacent to be theta. So this one is 15 because this side here is also what? Is also 15. Exactly. So that's why the opposite here is also 15, because they are the same. This line and this line, they are what? They are the same. So the using the tangent to find this angle alpha, so we have opposites over adjacent, which is equal to 15 over 20. That is, opposite is 15, then adjacent is what? 20. So if you use write 15 over 20, then 5 can go in 15 3 times, then 5 can go in 24 times. Now to find this angle, so you can divide both sides by tan. So here we now have alpha is equal to arctan 3 over 4. Arctan 3 over 4. So that is the end of this example 1.